a fan controlled exercise. Okay. So if there is any issue in between, you can kindly tell me that this is the issue. Meanwhile, let me just, yeah. So is the screen visible to you all? Kindly respond on the chat box. Okay. 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 So most of you know that we have covered an example of a pulsating signal, right? Am I correct? So we all have taken an example of a pulsating signal, and we all know that how difficult it was to present a single pulsating signal. And let me just share my entire screen. Let me just show you the example. All right. So this was the example for creating a pulsating signal. Am I correct or not? So where you had P trigger, N trigger, you had timers, you had and scan RLO. Okay. So rather using this particular signal for generating a pulsating output, what we can do, we can use a shortcut. Today, the very first thing that we are going to cover is that particular shortcut. Okay. And for that, what we are going to do, let me just start from the scratch. Save it. Yes. Let us save this particular example and then just close this example also. Okay. Let us start from scratch. Okay. Now you need to repeat and you need to tell me that what are the steps that I am going to take. Okay. So I need answers from all of you. Here, your portal. This is yours. So what is the next step? I will create a new project. Okay, let me name it as sample and control. Okay. Now what is the next step? What is the next step, class? We will add CPU. Yes, very correct. Very correct, Muskan. We are going to add a CPU to it. We will configure a device. Add a new device. So what kind of device we have at Automation Lab? What kind of device we have at Automation Lab? And what kind of device we have at Mechatronics Lab? So as far as 1200 series CPU is concerned, what kind of device do we have? Yeah, this is 1214C, and DC is in mechatronics, and AC/DC relay auto is in automation. Yeah, very correct. Very correct. Yeah. So let us go with DC only. Okay. Let us just start with the version 4.2. We will add it. And now your CPU is here. Okay. We can select the CPU. We can compile it or download it. Or what we can do, we can start with a PLC simulator. Once the PLC simulator is started, we will have a window which will ask it to connect. So we can use that particular PLC simulator. We can load this and it will be connected to your PLC. We will start module. Okay, we'll start the module and we will finish this. Now you have a rather than a separate physical controller of PLC, now you have a PLC sim which is attached to your replica of the controller which will be communicated. So your TIA portal is going to be communicated with this PLC sim rather than a dedicated physical controller. Okay, so now it is connected. Okay, now it is connected. Now let us just quickly move to our OB. We are not giving addressing a particular addressing to it. We'll just wait for it. What we can do right now is that at this present moment, what we have is we can have a output and an input and an output. Let me address it as M100.1. Okay, let me address that. And 2 0 not 0 to 0.0. Okay, so when your memory bit is going to get excited, your Q0.0 is going to get excited. Okay, we can compile it, we can download this, we can load it. Okay, and by the full view we can also have a watch. Okay, we can modify this memory bit also. Okay, we can modify it to 1 and we will get, since it is a you can say memory bit, you can modify its value. If it had been I0.0, so we would not have been able to modify it. Okay, but what I want to do is, please focus on this. This was our pulsating signal. For those who have not those who might not have covered this, let me just tell you that this is just an example of a pulsating signal where your signal is pulsating. So that output here, the output here will be of pulsating. So it will be plus 0, plus 0. And we can have the setting according to this seconds. Okay, so this is how it is going to work. But the main thing that you need to know is that this is quite a complex structure. Am I correct? This is a quite a complex structure. Rather, we can have a very easy structure regarding that. You can just what see how much effort you can escape from when you have this kind of structure where this can be pulsating. Okay, so what we are going to do now, we are going to make that particular system. So my monitoring is off. I am in an offline mode. What you need to do is, will go to your PLC and you will click to your PLC, and here you can see the tabs, the general information tabs. Here you have info caps, but you go to properties. Now when you go to your properties, you have general properties where you have project information, catalog information, identification and maintenance. Okay, in all these you can have the details, but what we need to address right now is our system and clock memory, where there is pulse generator. Now here you have system and clock memory. Here you don't need to give system memory bits to a system bit. What we need to do is enable the clock memory. So now you can see there is a clock associated to a memory bit, but rather than 0, what I am going to do, I am going to associate a address of 100. Okay, so now you see when I have changed the address from 0 to 100, so memory M0.0 M0 dot 1 has been converted to 100.0, 100.1, 100.2. Okay. So why I have used this particular exercise? Can anyone tell me that why I have changed it from 0 to 100? Can anyone answer me that question? Again, any answer is any kind of answer will is welcomed. I need answers from all of you. It doesn't matter whether it is right or wrong. What might be the reason that I have changed from 0 to 100? Why I have given 100 memory bit? Class, any kind of answer is welcomed. Kindly respond. Timer has used MD0. Yeah, correct. Timer uses MD0. Few more answers. Very good, Sahil. Class answers, please. Yeah, yeah. A very correct kind of answer. Very good, Sahil. I need more answers from others also. Kindly participate in the conversation class. So I need answer from Abhay, Adarsh, Alok, Ankush, Aprajita, Bhanu, Divyam, Hitesh, Kalpana, Khushbu, Lokeshwar, Muskan, Nayan, Rahul, Rajkumar, Raj Nandini, Ritik, Sahil. I need answers from your side. Kindly respond on the chat box. Yeah. So Sahil Gupta has very correctly mentioned that yes, it can overlap. Okay, so that is why we give a very high number associated to it, M100.0, because M100 memory, what happens is that when we use a very large kind of PLC program, so you use memory bits a lot in the creation of a particular program, and when you use it, you might have been using the memory bits as M0.1, 0.2, and it can reach to a very high number. Okay, so that is why I have associated a higher number. It is a standard practice that you associate a higher number of memory bit to a clock cycle so that there is no overlap. Okay, understood. Now at least can you respond that whether you get it or not? Yes or no? Did you get it? Kindly respond as yes or no. Okay. Now when I have shifted, when I have created this, okay, when I have created this, now what I can do, I can just compile it and load it. Okay, so now you can see that in your PLC tags, in your default tag table, you have memory bits associated to the clocks. Okay, now this clock can directly work according to your input. Okay, now what I am going to do, I am going to associate M0. So we can just have a look at the tag table that we have 100, 100.0, 100.1, 100.2, and 100.3. We are just going to take these three bits. Okay. So just let me copy this. Control. And let me just remove this tag and just delete this tag also. And let me just copy this it. Okay, and let me give a address of m100.0, which was your clock 10 hertz cycle, m100.1, which is your 5, and m100.2. Okay, and let me give an output of q0.0, q0.1, q0.2. Okay, uh, just let us look at the default table. We have 100.1 as clock cycle, and we can have tag name associated. Okay, so just remove this tag, because this tag was used twice, so that was showing a error. Okay, you can delete this row. You can, rather you can delete this entire row. Okay, so it had already overlapped because I have used 100.1 as a sample. Okay, so now you have m100.1, 500. Okay, now let us just simulate it. Okay, first of all we need to compile it, and then we need to download it. Okay, and then we will start the simulation. Yeah. Let us compile it, download it, load it, and start module. We have not given the start module, so that's why it was not starting. Started. Okay. Now let us just modify it to 0. Okay. So it is not getting modified. But now you can see that here this clock cycle is not getting modified from 0 to 1. Rather, it is working on a particular clock cycle. So now you can see this output. It is working on 10 hertz. Okay, and this one is working on 5 hertz, and this is working on 2.5 hertz. Okay, okay, so if I will go back to the offline session, let me just add another address to it, and let me just quote it as i0.0, 0.1, i0.2. Okay, now if I will again compile it, download it, load this, and start the module, then these clock cycles are working but not activated at this point of time. But can I modify from here? Modify to 1? No, it will not be modified. So for modifying a input, you can modify a memory bit, but for an input bit, what you need to do, you need to have a actuation, and that actuation is provided by your PLC sim. The input is provided by your PLC sim. You can add a new project, project 21. You can add that particular project. You can create this. You have your sim tables. Yeah. Now your PLC is communicated with your PLC sim now. Okay. You will have your simulation table. Now you can see here. Let me use I0 dot 0 first. Okay, and if I will drag it down, I will have I0 dot 1, I0 dot 2 also. Okay, now if I am modifying it to 1 from 0 to 1, your input cycle of 10 hertz is activated. When I'm modifying this to 1, then this is your, let me again transfer it to false. This is your 5 kilohertz. Okay, and I'm again pushing it to 1, and this is your 2.5 hertz cycle. So did you get it, class? Did you get it? Was it easy? Kindly respond on the chat box. Yeah. Okay. 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 So I have a question for you now. Okay. The step, I think you know how to approach a particular problem during PLC programming. First, you need to draw a tag table. Am I correct or not? First, you need to draw a table. Then you need to go logic by logic, and then you need to make a program. Okay, I think these steps are pretty much clear to you. Now we are going to have a question. Okay, and you need to just try by yourself to get an answer, and we will cover that quickly. Okay, so this is your question. This is your question. Okay, so this is a fan control unit. Okay, this exercise is not covered, right? Is this covered? This exercise is covered. I think it is not covered. Yeah, it is not covered. Okay, 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 okay. We'll go step by step. Okay, so the very first thing that you need to understand is about the process. What is processing? This is your fan. You have fan 1, fan 2, fan 3. Okay, this is your contactor. Again, you know that your contactor can be on or off. This is your fault condition. Okay, and kindly note that these all are your, what kind of switch is this? Is it NO type of switch or NC type of switch? Kindly respond on the chat box. Is it NO or NC? Yes, it is NC type of contact. Yeah. Okay. So now let us see that what does the question says. Okay. This is your fan. This is your fault status on healthy, and this is your start switch. Okay. Now the question says that you need to make a ladder logic program where your S naught is turned on. When, if your S naught is turned on, then following should happen. When your S naught is switched on, your fan 1 and fan 2 should be switched on. Fan 1 and fan 2 will be switched on. Okay, then your main contactor K1 will be closed. That means this circuit will be completed. Okay, then your system on lamp L1, this system lamp, this is a lamp. Okay, this should on, should turn on. Okay, now when you have switched on, your contactor is now been in contact. This is a closed loop. Your fan 1 and fan 2 will be on, and your supply on indication lamp will be on. Then after that, if fan 1 and fan 2 fail, how will they fail? They can be, these faults can be from here. So what will happen if they fail? This contact will be, this is a normally closed contact, this will be an open contact. Okay, so let me just brief you about this, that what is going to happen here. This is your close contact. Okay, normally close contact, you can say. When there will be a fault here, what is going to happen? This contact this contact is going to be a open contact. Okay, when a fault is there, this contact is going to be a open contact. Okay, and if there is no fault, then this is going to be a closed contact. So you are going to get an input. Kindly focus on this thing, that you are going to get an input until and unless there is no fault. Okay, now let us switch on to this. So when fan 1 and fan 2 fails, then the standby fan 3 should turn on. It should be or. Okay, so when either of the fan, if fan 1 fails, then fan 2 and fan 3 should be in operation, and if fan 2 fails, then fan 1 and fan 3 should be in operation. If either one of them fails, then your fan 3 will turn on. But when two out of the provided three fans, okay, if two out of the provided three fans fail, then what will happen? The load that was divided on two will be just pushed to a single fan. So that should also not be done. So your main contactor K1 should drop, and your system on the lamp L1 should flash a 5 hertz frequency. Okay, so the very first step that you need to do is that you need to answer me on the WhatsApp group that what will be the PLC tags. Okay, just quickly answer me that question and then we'll move forward. Okay, meanwhile, I'll just discard this. You understood the question? Let me just repeat it again. So this is your S0 input switch. Okay, so this will be your I0 dot say I0 dot 0. What kind of other input that you are getting? You are getting an input in the form of these fault switches. Okay, so you will get an input from fan F1, F2, F3. Okay, so this will be your input, this will be your input, this will be your input, this will be your input. Output you will have fan 1, fan 2, fan 3. You will have a contactor K1, okay, and your lamp. Okay, so your output will be 1, 2, 3, 4, 5, something sort of this. Okay, so you need to give an addressing. For example, for S0 you are going to give I0 dot 0, for F1 I0 dot 1, F2 I0 dot 3, F3 I0 dot 4. For fan you are going to give Q0 dot 0, Q0 dot 1, Q0 dot 3. For LED lamp Q0 dot 4. For contactor Q0 dot 0. Okay, so that kind of tag table you need to draw and you need to answer me on it to me on WhatsApp. Okay, quickly, we have a shortage of time. Do it as much quickly as possible. Even if it is wrong or right, it doesn't matter, but your answer is important. Okay,
Sir, can you send this question to chat box?
uh, through chat box. Yeah, I can just copy this question to.
Yeah, yes.
Yeah, I can do that. So I will just answer this in three parts because it has word limit also. So yeah, I've done that. Yeah, you have the whole question, and what I will do is that I will just also put it on full screen, and you have just um, 5 minutes to answer this. Okay, so it doesn't matter whether your answer is wrong or right, but your answer should be there. Okay, that matters. Yes, Ritik, you are right. Very correct. Yeah, Adarsh, very correct. You are also right. Meanwhile, I'm just repeating this question few more times so that you just understand what the question is. So the question says that when your switch S0 is started, okay, and it will start, your contactor K1 will be activated, because of which your fan 1 and fan 2 are going to get started. Okay. If there is a fault in fan 1 or fault in fan 2, okay, so for example, if there is a fault in fan 1 only, then what will happen? Your fan 2 and fan 3 will start. If there is fault only in fan 2, then your fan 1 and fan 3 will be starting. But if there is fault in 2, for example, F1 and F2, or F1 and F3, or F2 and F3, then it will be a different case. Okay. And now you also need a memory bit for that. And that we will talk later. Scan, your answer is also correct. Yeah, start I0.0, 0.1, and yeah, correct. Correct, you might have addressed it 0.3 also. It doesn't matter, Muskan. But yeah, correct. Very correct. Then your answer is also correct. Yeah, yeah, you all have addressed it correctly. Lamp is Q0 dot. What is Hitesh? What is I0.1 supply? What kind of supply is that? Yeah, you can say that. What is main supply? Main supply is associated to contactor only. The supply don't need an additional input. It is always there. The supply will be connected through contactor K1 only. You need not to give that. Okay. For I think for Hitesh and Kalpana, this is an issue. Most of you have given a main supply, I think. No. So for main supply, it is not required. Okay. So I think Kalpana, Hitesh, and Varun. Bhanu, your answer is also correct. Power supply I0.4 not required. Bhanu, because we have a contactor associated to it. Okay. If you have given that input to output to a contactor, you don't need an input of power supply. Yes, Kush, your answer is also correct. So most of you have are aligned to it. I think it doesn't. It's not a matter of fact. Okay. So again, let me repeat the question for you. Uh, So when your start S0 is turned on, I will be a little bit repetitive, but this is very much important for the understanding of the problem. Okay. So we have already repeated it, but once more I want to repeat it because let us have a better understanding. When this S0 is switched on, your K1 will be in closed loop, your fan 1 and fan 2 will be starting. Okay, because of the activation of K1. That means that when your switch is on, your K1 is on. When your K1 is on, your fan 1 and fan 2 is on. Okay. But if there is a fault in F1, then your fan 3 will start. Again, your S0 should be started and your K1 should be activated. Okay. Then if F2 is at fault and F1 is in a correct position, then F1 and F3 will run. If in any of the case, whether it is F1 and F2, F2 and F3, or F1 and F3 are at fault, then there will be a condition of a major fault, you can say. And because of that particular fault, what is going to happen? What is going to happen? Your major fault condition is going to prevail, and that is that when two fans out of the provided three fans fail, then your main contactor K1 will be dropped. It will not more be excited. Okay. And your system on the lamp L1 should flash at 5 hertz frequency. So this lamp, which was continuously lightening because of the healthy condition, when there will be a major fault, when fault F1 and F2 are, you can say, or F1 and F3 or F2 and F3 are collectively at the fault, then what is going to happen? It is going to switch off the K1 and this LED is now going to blink at a frequency of 5 hertz. Okay. So what you need to do, you draw, just try to draw it for 4 to 5 minutes. Okay. Then we will continue. Or you can take 10 minutes associated to it. Just try to draw the ladder logic, how you will draw. Just a very quick flashback about this frequency, your flashing. You can take this memory bit. So this is M100.1. Okay, need not to have an actual activation. From this, you are going to have an activation. Okay, just try it for few minutes and then we'll continue. Recommended. Hello, hello. Am I audible, class? Uh, yeah, I think I am audible. Yeah. Class, it is very much recommended that you go step by step. Okay, just I'm telling you that what kind of step that you need to take. Okay, Just for example, start with each and every sentence, because there can be a this is an interrelated program of PLC. So what you need to do is, this ladder logic is interconnected to each other. So what you should do, you should first go step by step. So for example, when you have this, that when start S naught is turned on, then you can make a logic for this only. That when S naught is on, then your contactor K1 is closed. Okay, this is your main branch. Okay, so this is related. Now when K1 is on, your fan 1 and fan 2 should be on, and your lamp L1 be on. So S naught will be sub branch to K1, and then fan 2, fan 1, L1 will be on. Okay, and then you should have the logic of fan 1 and fan 2, and then you try to interconnect it. Okay, you try to interconnect it. Go one by one and try to interconnect it, because interconnection is very much important. Okay, you need to interconnect each and every statement, and you need to address every problem statement that has been given into this exercise. Even if you are not able to make or interconnect each and every step, the only thing that you need to do is at least try to make simple, very single line ladder logic for each. Meanwhile, what I will do is, I will you just try to work on the PLC program or ladder logic. Meanwhile, what I am going to do, I am just going to create the tag table. Okay, so you have this tag table now. Let me just remove this. And let me refresh this and remove this. So let me remove this. Clock byte we can take, all the memories, and we can delete. Okay, and let us just, for ease of, you can say, operation, what we can do, we can just cut these, add a new tag table, and paste it here. Okay, so now we know that we have our clock cycle, and we can just use this clock cycle 100.1. Okay, and now we can just make a default tag table. So let me just start with the addressing, or you can say tagging. So I have S0 will be I0.0. Then let me take as fault 1 was my input, fault 1. Okay, we will have fault 2 and fault 3 also. Okay, now I will have a major fault. Okay, I will also have a major fault where your two fans were at fault. Okay, what I will do, I will address, I will provide it a memory address, because it is a situation, and I need to create a logic for that particular situation. So what I don't have a particular input for that, so I will create a memory address for it. Okay, Then you have your contactor K1. You had your contactor K1. You had fan 1 and 1, and your K1 will be Q0 dot 0. This will be Q0 dot. Okay. Now you can have fan 2 and fan 3 also, and you can have a lamp also. Can delete this, this, and this. So class, kindly respond. Shall I wait or shall I start? Okay, on the last time. Okay, okay. Sahil, logic is partially correct. But what about the contactor? That once when the contactor starts, all the fans start. Yeah. If there is main fault, then your contactor will not start. Yeah. Yes, Sahil, very correct. But still, minor changes are required. So your clock cycle will be activated because of something. You have taken minimum fault also. Yes, Sahil, it is correct. Minor changes are there, but a very correct logic. Good, Sahil, very good. Class, kindly send your responses, then we will continue. If it is not completed, then also kindly send your responses, and then we will continue. We will take it step by step. There is a restriction of time, so therefore we can't give much time on that. Class, your responses. So, Abhay, Adarsh, Alok, Ankush, Rajita, Banu, Divyam, where are your answers? Please share it on WhatsApp. Oh, I think electrical students might not be on this particular group. Okay, so class, should I continue now? I think it's I got the response from Ritik also. Yes, Ritik, very correct, very correct, very correct. Ritik, you need to add one more thing. Uh, your major fault. Okay, so your major fault will not Acha, you have already given a reset to the contactor. Yeah, yeah, this can work. Ritik, it is correct. What you have done is that you have directly added this to your reset contactor. Yeah, this is correct. Correct. Uh, Ritik, very correct. This will also work. Ritik, this is also correct. So your conditions are fulfilled when your switch S0 is open and but Ritik, there is one condition. What actually happens physically is, Ritik, are you listening to me? Your your contactor should activate the fans rather than once your contactor is activated, they will activate the fans. What you have done is also correct, but your K1 was your output also, right? Your Q0.3, yeah, this is your contactor, and when your contactor is in connection, then your contactor should have initiated the steps. Rest is very much fine, but you understood, right? In industries, what happens is that the contact, it is not your direct switch. There is a contactor that contacts, and because of that contactor, your line works. Okay. So because your switch S not is on, your fan can be on without the use of contactor. That should not happen, right? Am I correct or not? Okay. So it will not work in that manner. Class, shall we continue now? Class, kindly respond on the chat box. Kindly respond on the chat box. Shall we continue? Shall I explain this? Yeah. So just take a deep breath. It's not necessary. I just wanted that you should take an optimum amount of time while understanding the question. We will go step by step. Okay. So what we have done till now is we have made the PLC tag. Okay. So this was our default tag table as not fault 1, fault 2, fault 3, K1, K0, etc. Now let us start with the question. So we know that we will have an input and we will have an output. Okay. We will go one by one. This is our question. So when your input S0 is started, okay, your fan 1 and fan 2 will be turned on, but your main contactor is closed. So you can say that it is closed. That means that your Q0.0 K1 is excited. Okay. So we will first draw that. Okay. So this will be your I0.0, which is your S0, and this will be your contactor, which is your Q0.0. Okay. Now, after when your S0 is started, your contactor is on. What does that mean? That when your S0 is started, your contactor is on. Okay. So let me take this Q0.0, 0.0. What is going to happen? Your lamp will also be on. Lamp will also be on. Okay. So your lamp will also be on. So what we are going to do? We are going to give an output to this. This will be your lamp Q0.4. Q0.4. Okay. Now, when your contactor is activated, we will use a sub branch. Okay, when your q0.0 is activated, okay, and your there is one more input which is your fault, and there is no fault in fault 1. Okay, if there is no fault in fan 1, there is no fault 1, then your fan 1 will be on, which is your q0.1. Right, this was our logic. When switch is on, your contactor is on. When your contactor and switch is on, your lamp is on. When your switch contactor is on and there is no fault in 1, your fan 1 is going to get started. Okay, again we will move to this. Okay, from here we again we can say that, or you can just use, you, you can just delete this, and you can add a sub branch here. So when there is no fault 1, then your q0, your contactor is on. If there is no fault 1, then your fan 1 is going to get started, and if there is no fault here, then your fan 2 will be started. Okay, again we can take the contactor k1. Okay, now this was the condition of normal condition. This can be fulfilled. Now your both fans can be started. So this condition is fulfilled till now. When your S0 is turned on, your contactor K1, okay, your contactor K1 is started. Okay, fan 1, 2 and fan 1 and fan 2 should be on. Fan 1 and 2 are on. Fan 1 and fan 2 are on. If there is no fault, okay, and your system is on, and your system lamp is on. Okay, now let us move to other things. Now we know that if there is a fault in fault 1 or whether there is a fault 2, okay, then your alternate fan will be on. Okay, what does that mean? Let us take this and an output, take a sub branch, take this, I can say you can take this, delete this one and delete this one and add this and add an out. Okay, now you can say that when I0.1, let me delete this, let me just add it here, add this. Okay, when there is no fault 1 but there is fault 2, when there is no fault 2 but fault 1, both the conditions are prevailing. Okay, if anyone is, single one is at fault, and this will be your I0.3. Now you can see when fan 3 is not faulty, fan 1 is not faulty, and fan 2 is faulty, then your fan 3 will start Q0.3. It means this, Okay, when your contactor is on, your fan 1 is faulty, fan 2 is not faulty, fan 3 is not faulty, then your fan 3 is going to get started. Okay, this logic prevails. हेलो हेलो क्लास में हूँ अभी मैं बात करता हूँ हेलो बस 15 मिनट में खत्म कीजिए ठीक है ठीक है yeah. So this was the situation. So what we have completed, statement by statement we have gone. Of fan 1 and fan 2 fails, then fan 3 should turn up. We have gone statement to statement. Okay, it is very important for you to go statement to statement and change it accordingly. Okay, so we have started with S naught, then we have started with main contactor, system lamp, fan 1 and fan 2, then what will happen when fan 1 and fan 2. Now let us move to third statement. When two out of the provided three fans fail, then there will be a condition. Okay, so the very first thing that we are going to do is that what will happen when two out of the three fans fail. So let us just first draw the condition. Okay, kindly focus on this particular step because this particular step is important. And all these steps are after the starting of your switch S naught. Okay, so let me take two NC contact and one NO. Then let me take another NC NO NC. Then let me take another NO NC NC. Let me join this with each other. Okay, and let me give an output. This will be my I0.0. Will be my I0.1, I0.3. This will be I0.0. This will be I0.1, I0.0, I0.1, I0.3, I0.0, and I will provide a memory bit address to it. Now, to define the last statement, when two fans out of the provided three fan fail, I have created a condition and provided a memory bit, associated a memory bit to it. Okay, so this is the associated memory bit. What is going to happen? Let us look at that. Your main contactor K1 should close. Okay, so if the major fault occurs, your K1 should not get excited. So what we will use? We will use an NC circuit here, NC contact here, and will provide it a memory bit here. This is completed. Now, what it is saying that after this, what is going to happen? Let us use another branch here. If S0 is on, the K1 is not working now. The K1 will not work. Okay, But what will happen? And also, yeah. So if memory bit activates, if there is a major fault, then your memory bit that we have used was M100.1, right? So a clock cycle of 5 hertz is going to work. So we have gone statement to statement. Uh, Let me just repeat it once again with respect to statement what we have done. So let us just take one by one. So when we start, S naught is turned on. Okay, so first we will start the S naught. Okay, you can make in a single line structure also for that. What is going to happen? Fan 1 and fan 2 should turn on. So fan 1 and fan 2 will on only when contactor is on. So first we will look to the contactor. We normally always look that whether we do have a uh, you can say logic for contactor, yes or no. If there is a logic, we first go for that thing. Okay, so we have gone to our contactor cable. Then when contactor is on, your lamp will be on. Then when your switch is on, contactor is on, your fan 1 and fan 2 will be on. Okay, but if there is fault 1, then your fan will not on. If there is fault 2, then your fan 2 will not on. If there is a fault in fan 1 or fault fan 2, then what is the condition? If there is the fault in fan 2, then your fan 1 and fan 3 will be in the good condition and your fan 3 will be on and your fan 1 was already on. Okay, similarly in the case of fault at the fan 2, your fan 2 will be off and instead of fan 2 your fan 3 will be on. So you will have two fans running at a single instance of time. Okay, but if your two fans are not working, if two fans are not working, okay, then there will be a major fault and your contactor will be dropped. Okay, class. Is there any doubt till now, class? Kindly confirm on the chat box. Is there any doubt till now? Class, is there any doubt? No. Others, is there any doubt? I got only very few answers from Hitend, Ankush, Bhanu. Yeah. So I have gone step by step. All the statements are now completed. Now I will compile it. I will download it, load this, and will move to this. I will have I0.0. Okay. I0.0. Okay. I will have I0.1. Now the important thing that you should be knowing is that we have discussed previously that these are NC contact. Okay, so by default their condition will be 1, not 0. Okay, so this the physical switch is NC. So by default its condition will be 1 rather than 0. Understood? So in PLC sim the default condition will be 1, 1 and 1. That means there is no fault. Okay, and now let us see what is the condition. So when there is no fault, your Q0.0 nothing is working. Now let us see if we will start the switch, what will happen. So let me convert the position from 0 to 1. Okay. Your switch is on, your contactor is on, your lamp is on, your fan 1 is on, fan 2 is on, the fan 3 is off, and there is no major fault. Okay. Now let us just look into what if there is a fault in fan 1. Fault can be high sound, high noise, vibration also. Okay. Because of that, that contact has been left. Now what will happen? The contactor K1 is okay, your lamp is running, your fan 1 is off, your fan 2 is on, rather than fan 1 your fan 3 is on. Okay. Now what shall we do? We shall just give this value 0 and this 1. What happens when your fault 2 occurs? So when your fault 2 occurs, your fan 2 is not working, your fan 3 is working, and fan 1 is working. So rather than fan 2, your fan 3 is working, and rest are the same conditions. Now let us see what is going to happen when both are in false conditions. When both are in false condition, your fan 3 is not going to work. Why? Because your major fault had been occurred. Okay. And when your major fault has been occurred, then what is going to happen? You are going to get a clock cycle. What I have done? Okay. What I have done is that I have done this mistakenly. This should be NO contact and this should be NC contact. Am I correct? Why? Because this is a major fault which will be in an active state. Major fault is not in active state. Why? No, I think I have done something wrong here. I 0.0, 0.1, 0.3. This is working. Oh, I have used I 0.0. Rather, it will be 0.1, 0.2, 0.3. This is my fault. Sorry, class. Uh, you understood what I have done wrong? My addressing is not correct. Class, did you understood what wrong I did? My addressing was not correct. Yeah, that was mistake from my side. My addressing was not correct. Okay, we need to pick those things also. I expect that you should be able to pick these faults. I 0.1, I 0.2, I 0.1, I 0.2. Not 2. I'm going to compile it, download it, load it. Now there is a major fault. Okay, there is a major fault, and your lamp will be blinking. Now your lamp is blinking. Okay, your contactor is not on, the lamp is blinking, none of your fan is working. Understood, class? Is there any doubt? Have you understood? Kindly respond on the chat box. Okay, class. So let us finish the session here. It's 3:28. That's all from my side. And From 4, you have a session on robotics by Mr. Ajay. Thank you, class.